Alright, what we're talking about today is Lesson 54, using linear programming. Linear programming is a mathematical technique that allows you to make optimal decisions from a complex set of choices. In linear programming, you are looking for the maximum or minimum value of an objective function, subject to certain constraints. The constraints are given as linear equations or inequalities. Okay, most of ours are going to be inequalities. In the graph, the shaded area is known as the feasible region. Okay, in this case, they're saying that this is the shaded area. Okay, this is the feasible region. And all possible solutions are found there. Okay, that's the darkest shaded area. Note that sometimes it'll be shaded here and here, but where it's overlapped the most is the solution set, right? Okay, what's important to you about the shaded region are the corners of the feasible region, because those are the solutions that we care about the most. Okay, that's where we're going to find our minimum or our maximum, and those are the vertices of the feasible region. Okay, so example 1, graphing a linear programming problem. A marketing manager is coordinating an ad campaign. TV ads are $2,000 and reach 10,000 people. Radio ads are $500 and reach 5,000 people. The target size of the audience for this marketing campaign is at least 100,000 people. He wants to buy no more than 10 TV ads and no more than, whoops, I have the wrong marker in my hand, and no more than the 15 radio ads. Okay? Says, how can the marketing manager minimize his costs within these conditions? If he's wanting to minimize his costs, what is he wanting to do? Make it smaller. He wants to pay the least amount and reach the most people. That's what he's trying to do. Okay? So what we have to do is we have to come up with some information to help us figure this out. So what we need to look at are, first of all, we're dealing with two different things. Those things are TV ads and radio ads. I'm going to call that my X and my Y. So X will be TV ads and Y will be radio ads. Not particularly, but it's easier to keep them straight if you do the first one X, second one Y, just that way, so that you're not getting them mixed up. Does that make sense? Okay. So what we have now is we also have our cost function, or our objective function, the one that we care about as far as finding that solution. So the cost, okay, our cost function is equal to, what's he paying again? $2,000 for what? TV. So 2,000X plus 500Y, because that's what he pays for the radio ads. That's going to be important to us in the future. All right, other things that we know. We know that with the TV ads, he reaches 10,000 people. With the radio ads, he reaches 5,000 people, and he wants to reach at least 100,000 people. So I can write an equation based on that information too, right? An inequality. Okay, so for that inequality, for TV ads, how many people does he reach? 10,000. So I'm going to say we have 10,000 people reach with TV ads, plus how many people with those radio ads? 5,000. And he wants to reach at least. What does at least mean? It can't be less than. So it has to be greater than or equal to. Greater than or equal to how many people? 100,000. Okay. So now what we know is that he wants to buy no more than 10 TV ads. So if he wants to buy no more than 10, he wants to buy 10 or less. Okay? 10 or less. The minimum that he could buy would be how many? Minimum. 0. He doesn't have to buy any, does he? No, he doesn't have to buy any. So we're going from 0 to 10. So that means that X ranges from 0 to 10. Let me make that a 10, not a 0. Okay? Does that make sense? What about Y? What would Y be? 0 to 15. Okay, 0 is less than or equal to y, which is less than or equal to 15. 15 radioads right there. No more than 15 radioads. Okay. Now we have all the information we need to figure this bad boy out. Okay. If I'm saying from 0 to 10 for x, that means that the range that's possible is from 0 to 10. For y, it's from 0 to 15, right? That's the area that I care about. What this is telling me is that I only care about the first quadrant here. I don't care about any negative numbers. Does that make sense? So whenever I graph it, I'm only looking at the first quadrant. Okay? And whenever I graph this part, when I graph this, I'm saying from 0 to 10, right? Which is the same as saying x is less than or equal to 10. Because I'm going to go to 10, which I'm going to say is right here for my x. And I'm going to draw a line. Okay, because that's where x is equal to 10, right? But where is it less than 10? To the left of it. And I can draw it like this because, again, I do not care about any negative numbers. Does that make sense? Okay, so now I'm going to do the same thing for y. I'm going to graph what? 15. Y is less than or equal to 15. So that's going to be, we're going to call it here. Okay? So that's going to be a horizontal line. And where is it less than or equal to that? Below. Okay, it's equal to it at the line, but it's less than at or below the line. Okay, so right now my feasible region is this rectangle. Does everybody see that? Okay, there's one more thing I need to graph. And it's this. Okay, how am I going to graph this? Get y by itself. So what am I going to do? Subtract 10,000x from both sides. So I have 5,000y, that's 500. 5,000y is greater than or equal to negative 10,000x plus 100,000. Okay? I still need to get y by itself, so I need to 5,000 on both sides. Okay, so I get y is greater than or equal to negative 2x plus 20, right? Okay, whenever I graph this, I know that I have to start at what? That positive 20, okay? My intercept is going to be somewhere up here for that. Okay, 20. Now from there, it's obviously going what? Down. It's going to go down, negative 2 over 1, right? So it's going to look something like this. Alright, and where will I shade? Above or below? What's my sign? Greater than. So what do I shade? Above. I got to shade on top. So I'm shading here. So the feasible region that I care about is what? The triangle. I care about this region right here. Everybody see that? What points did I say I care about within that feasible region? The corners, all the vertices. I care about this point, and this point. Okay? One of them I can find very easily. The other two, not so much. Okay? Because this line that I drew, this red line, it's an estimate, right? Who knows how close I got? Okay? So there's one of those points I know. Top right point. What is that ordered pair? 10, 15, because it goes through those two lines, right? So this is 10, 15. Everybody with me at that point? All right, to figure out the rest, we're going to have to use our calculator. So we're going to get out our calculator, and we'll turn it on. And we're going to go to, is it on? Why are you not turning on? There we go. Second, quit. We are going to go to our y equals, clear out what's there if you have anything. And we're going to plug in this red line, which was negative 2x plus 20. No, don't worry about that. I know that we know how to do the shading, but if you do the shading, it's really hard to see. So whenever we have to use our trace tool, you can't see your trace tool because there's too much stuff going on, so we don't do that. We just care about the line. We've graphed it on our paper. We have a nice sketch of it that we have that, okay? So when I graph it, my window is going to be way off because I was working on other problems with the other class. So I'm going to go to Zoom Standard so I can see my standard window, and this is what I see. This isn't what I want to see, right? Looking at the graph that I drew, I want to use this information to set my window, right? So my window, I'm going to go to Window. My X minimum should be 0. My X max, we'll say 20. Our Y minimum, max, 20 is fine. Okay, graph. All right, so now we see our line, which looks just like the one I drew, right? Pretty close. So what I'm going to do now, you are just going to, I don't have time for real. So if you messed up, then you need to go back and watch this, okay? All right, so what we're going to do now is we're going to look at it in our table view, okay? Looking at our table view is going to help us figure out those coordinates. Because I can see this point right here is roughly, what would you say for the x-axis? 1 or 2? 2, maybe 4. Okay, I haven't drawn a very accurate graph, right? So 2 or 4. So I'm going to go to my table. Second table, or second graph. My table's messed up, so I'm going to change it so that it's not. Start at 0, 1. I'm going to set it so that it's the same as yours. Okay. All right, so here's my table, and we said that it's at about 2. Well, what do I want it to be for y at this point? What does it have to be? 15, because that's where it hits that line, that green line, right? So 15 falls somewhere between what? 2 and 3, because I'm at 16 and 14. Where exactly does it fall between 2 and 3? Halfway, so it's 2.5. I can check that by going to second table set and changing it to 0.5 for my change. That's what this little triangle means, change in the table. And when I go to my table and I go down to 2.5, what's it equal to? 15. So I know that excuse me, that ordered pair, whoops, I went black, is 2.5, 15, right? Are you good? Okay. This point here looks really close to what? On my x values. What's it look really close to? 10, based on what I've drawn, right? So let's look at our table. And let's go to x is 10. I'm going to change my table set back to a change of 1, just because it's faster. Okay, so going down to where x is equal to 10, what's y equal to? 0. Okay, so where x is equal to 10, that's where this line was, okay, which is what we need it to be anyways. It has to hit at that 10 because we don't care about anything past that, right? So we care about that one anyway. So it's 0. So that value is 10, 0. All right, so this is 10, 0. Now the way that we figure out the answer to the question, how to minimize his cost. So what we're going to make is we're going to make a table, an x, y, and then cost, which we said the function for cost was 2000x, equal sign. Cost equals 2000x plus 500y, right? So we said our cost function was. And I have 3 points that I'm going to try for this to see which one is going to minimize for him. So I have 2.515, I have 1015, and I have 10.0. Does everyone understand where I have gotten this information? Everybody good? Okay. So, what? I took the 3 vertices. All the vertices. Sometimes you'll have more than 3. Yeah. Does not matter the order. Okay, now what we're going to do is we're going to take our x and y, plug them into our cost function to find the cost. So 2,000 times 2.5 plus 500 times 15, what does that give me? 12,500. 2,000 times 10 plus 500 times 15. 27,500. Okay? 2,000 times 10 plus 500 times 0. $20,000. So how is he going to minimize his cost? What's the minimal cost here? $12,500, which means he's buying how many TV and how many radio ads? Right. Do you think he can buy a half of a radio ad, though? No, so we would probably say how many TV ads? We need to say 3 because he's got to reach a minimum of that many people. Okay, so we say 3 and 15 is what he would need to purchase. Does that make sense? Yes? Everybody with me? Because it said, the question asked, minimize his cost. If I want to minimize it, I want the lowest one. Sometimes it'll say maximize. Maybe they want to maximize their profit. Then I want the highest one. Yes. But I don't want to maximize my cost if I'm paying for something. I want to maximize my profit if I'm making money. Does that make sense? All right. Moving on. All right. Says, farmer needs to decide how much corn and soybeans to grow for the next harvest. The cost of corn seed is $80 per bag, while soybeans are $50 per bag. A bag of corn requires 2 acres of farmland, while soybeans require 1 acre. The farmer's acreage is 500 acres, and I also know that it takes 3 hours to plant a bag of corn, 2 hours to plant soybeans, and the farmer expects to need at least 2,500 hours of planting. How can the farmer manage costs for the next harvest? All right, the first thing we did last time was designate our X and Y, right? Right, so we're going to say X is corn and Y is beans. All right. Other information that I can take from this. I'm wanting to manage costs, okay? So I want to make a cost function, all right? So the cost, what is the cost? 80x plus 50y. Okay, $80 for corn, $50 for soybeans. All right. Now, some other constraints that we have, all right? I can write a couple of equations here based on acreage and time. Does everybody see that? What can I write for acreage? 2x, because 2 hours for beans plus what? Plus 1y for 1 hour for soybeans. Not hours, acres, excuse me, acres. 2 acres for corn, 1 acre for soybeans. Y less than or equal to? He only has 5,000 acres. His neighbors are probably not going to like it if he starts planting on their land. Well, they might if he pays for the seed. I don't know. All right, so the other one is for hours. What's my hours going to be? 3x, 3 hours for corn plus 2 hours for beans. And that needs to be, he says at least. At least means it has to be greater than or equal to 2,500 hours. Okay? Alright. Oh my gosh. Now the only other constraint we have is where we're graphing this information. And what location on a coordinate plane do you think we would want to graph this information? Y quadrant 1. It's got to be positive numbers. Can he buy negative amounts of corn? No. Can he spend negative hours? No. It has to be positive. So we're definitely dealing with the first quadrant. Okay. All right. Now, the only thing that I have to graph this time, though, are these 2 functions. These 2 inequalities. Does everybody see that? All right. The first one, what do I need to do? Get y by itself, so I'm going to subtract 2x. And that gives me y is less than or equal to? Right. All right, on the other one, what do I need to do? So I have 2y is greater than or equal to negative 3x plus 2,500. Now what? Divide by 2 on both sides. So I have y is greater than or equal to negative 3 halves x plus 1,250. All right, now whenever I graph these, I know that I'm going to start on the first one at what point? 5,000. I'm going to have a huge window here, right? All right, so I'm just going to give myself some estimates here. I'm going to say that this one's going to be blue and this one's going to be green just for the sake of looks. So if I start at 5,000, I'm going to say 5,000 is up here. All right? And I'm going down 2 over 1. All right? So it's not quite 1 over 1. It's a little faster than that. So I'm going to say it looks like this. All right? Where do I want to shade in relation to that? Below, because it's less than. Less than means below the line. So I'm shading here. Alright, the other one, I'm starting at 1250, so somewhere in this range. Alright, and I'm dropping not quite as fast as the other one, but still about the same rate, right? So it's going to look about like this. Where should I shade in relation to that? Pretend there's a straight line, please. Above it. So I'm shading this way. Alright, so the points that I care about are the vertices. Okay? My vertices are here, 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 and here. Does everybody see that? There are 4 this time. Does everyone see why it's those 4 vertices? The double shading there, everyone sees it? Okay, so there are 2 of them that I know very quickly, right? What's this vertice? 0, 5,000. This one? 0, 1250. And then on these 2, they're going to be easy to find because I'm going to look for where what? Where what's equal to 0? X. Where y is equal to 0, right? Because I don't go up or down at all. So I know that this is x something 0, right? This one is x something 0. So I'm going to use this information to help me figure that out in my calculator. I'm going to go to my y equals, clear out anything that's there, and I'm just going to do one at a time so that I don't have any confusion, okay? So the first one that I'm going to do is my negative 2x plus 5,000. When I graph it, do I see anything? No, because I need to change that window. So what do you think we should change our window to in this case? We need to change it to 5,000, right? So I have 5,000 here. Let's go ahead and change the other one to 5,000 also. The only thing that I would also change is I need to change my scale because 0 to 5,000, that's a lot of little tick marks, right? It doesn't have to be perfect. I'm going to say 500. Just so it's a nice big gap, okay? And I'm going to do it for both of them. What? Yes, well, x and y scale because we changed the x and the y axis. So now when I graph it, oh, look, I can see it, okay? So to figure out what this is, I'm going to say trace, and I'm going to go down. Oops, it's already right there. Look at that. So what is my x equal to and y is 0? 2,500. Okay, so this is my first one, right? My blue one. So I'm going to say 2,500 right there. I don't want to do that because it's erase it. Okay, now I want to work on the other one. So I'm going to go back to my y equals. And I'm going to clear it out, and I'm going to put negative 3/2 x plus 1250. Graph that. Everybody with me there? I'm going to trace it. Alright, not where I need to be. Huh? I can change the window. Let's change it so we can see it better. I'm going to set my maximum, let's say, to 2,000 instead, and we'll change it to 200 instead of 500 for the change. Okay, so now I can see it a little bit better. If I go to my trace tool, it doesn't have me where I need to be. So this time, what I'm going to do is I'm going to figure out about roughly where I need to be. Okay, so here at x is 829, I'm at about y equals 5. Does everybody see that? So I'm going to go to my table set, and I'm going to start at 829. Because I know y equals 5 is really close to y equals 0, and that's where I want to be. Does that make sense? So I'm going to start at that, and I'm going to leave it at a change of 1. So now I'm going to go to my table. Second graph gets me to table. And I go down here. I'm down to 3.5, 2, 0.5, negative 1. So somewhere between 0.5 and negative 1 is that 0 that I want, right? Which means it's going to be some kind of a decimal or fraction, right? So I'm going to go back to my table, and I know it falls between 833 and 834. So when I go to my table set, I'm going to start at 833. And I'm going to change my table change. Let's change it to a half and see what happens. Okay? So go to table from there. At 833 and a half, I go from 0.5 to negative 0.25. Still between those two, right? What's a fraction between, 0.25? So I could change it to a fourth. Let's see if that'll work. Alright, so now I go from, let's see, 0.125 to negative 0.25. So it's between those two now. So what's between a fourth and a half? No. A third. Let's try a third. So we go to our table set, and we don't want to write it as a decimal. Let's write it as the fraction because it's a repeating decimal, right? So I'm going to go back to my table. Look at that. 0.833.33333, which means 833 and a third. So I have 833 and 1/3. So again, I have to use my cost function to figure out my answer. So I'm going to have x, y, and I know that cost was equal to 80x plus 50y. Okay. And I have 4 points this time that I'm talking about. And those points are 0, 5,000, 0, 1250, 833 and 1/3, 0, and 2500, 0. So, in your calculator, I'm sorry? That's wrong. It's 833 and a third. I'm sorry. For where it's equal to 0. I did these beforehand to make sure I didn't make a mistake, so I do know it's 833 and a third. If you want to talk about it later, we can do that, but I got to keep going, okay? All right, so 0 and 5,000, what's my cost? 250,000. All right, 0, 1250, what's my cost? 62,500. 833 and a third and 0, my cost? Whoop, is it an answer, Blakely? Type, 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 let's go. $66,664 and 2,500, 0, 200,000. And what's the farmer wanting to do? Manage his costs. So what do you think that means he wants? He wants the lowest. He doesn't want to spend a lot of money. Okay, so that would be where he buys what? All soybeans. Okay, 1,250 bags of soybeans. Because why is soybeans? Yeah. Okay, moving on. We're going to do a little better than we did second hour because we didn't... we did skip example 3, and I'm thinking about skipping example 4 because I also need to talk about lesson 55. Okay, I need a thumbs up or thumbs down. Thumbs up, please go on to 55. Thumbs down, please stay on 54. All right, we're moving on. Okay, lesson 55, we're talking about finding probability. Blah, blah, blah. If you want to know this stuff, read it. Okay, theoretical probability. You have done theoretical probability since you were in middle school, probably all the way back in 5th and 6th grade, maybe even younger than that. And that is where you want the favorable outcomes over the total number of outcomes. Okay, favorable over total. That's theoretical probability. It's in theory. It didn't actually happen. Okay? That's whenever you're talking about flipping a coin, you've got a 50-50 chance. You got a 1/2 probability of getting heads because there's one head and two options, right? It's in theory. You didn't actually flip a coin and see what you got, right? Okay. So, blah, blah, blah. That's what I just said. Theoretical probability, all your outcomes must be equally likely, okay? That's important too. Because it doesn't work in theory if it's not equally likely. There's a lot more stuff that goes into it. So, calculating probability. A calculator is programmed to generate random integers from 1 to 100 inclusive when the enter button is pressed. What is p multiple of 20? What does p multiple of 20 mean? What's p mean? Probability of getting a multiple of 20. So from 1 to 100, what are my multiples of 20? 20, 40, 60, 80, 100. So how many multiples of 20 do I have? 5. So I have 5 favorable numbers out of how many total numbers? 100. I reduce that. I get 1 over 20, which is 0.05. Sweet. Okay. Estimate the probability that a point chosen randomly inside the figure is in the shaded region. So if I want the shaded region, that's my favorable. Okay, how am I going to find the area of the shaded region, sir? That's going to be the shaded region? Ah, there we go. I want to find the area of the square, and I want to subtract the area of the circle. So I'm going to take the square minus the circle over, what's my total area? The total area is the 144, the square. So, to find the area of that square, I know I'm going to take 12 squared minus, how do I find the area of a circle? Pi times radius squared. So the circle is going to be pi times the radius. What's the radius of that circle? Half the diameter, which is going to be 6. Square it over that 12 squared. Now let's figure out what that probability is. So 36 times pi is... Take that from 144. 144 minus second answer. Enter. What did you get, Mad Dog? 30.9 over 144 gives me roughly, give me 3 decimal places. 0.214. That's the probability. So a little more than 20% chance, right? With me on that. Okay, moving on. Calculating probability for permutations and combinations. When we're dealing with permutation and combination, what's important for you to remember is that for permutations, order matters. Okay? For combinations, what do you think? Order doesn't matter. Okay. So, on A, it says all the parking spaces in a lot are labeled with 2 different digits. Okay, so all of them are 2-digit numbers. So that each parking space is labeled differently. Okay? That's important for you to realize. 2 different numbers. Okay? So if it's 2 different numbers, that means that you don't have any doubles. Does that make sense? No 11, because that would be 1 and 1. It has to be different. Does that make sense? Alright. What is the probability that a parking spot chosen at random is labeled with 2 even digits? So my question to you, is this a permutation or a combination? Why? She says permutation. Why? Quinn? Not necessarily because of that. Okay, let me tell you. Let me ask you something. Give me 2 digits. Any 2 digits. Give them. 1 and 4. Is 1 and 4 the same as 4 and 1? 14 is the same as 41? No. Order matters. Does that make sense? Order matters? Yeah? So that's a permutation, right? Alright, so we're dealing with permutation. The total number of digits that I can plug in one spot. How many digits are there that I could plug into one spot? So I could plug in 1. I could plug in 1 through 9. There's one more digit I could plug in, though. 0. So 0 through 9. So how many digits are there? 10 total. How many am I choosing for each space? 2. This is going to give me my total number. Okay, what's my total number then? Remember, we go to math, over to probability, 90. All right, now it wants to know the probability that it's 2 even digits. Okay, so we want to know how many of them are going to be both even digits. So I know that on my little sign for each parking spot, okay, there are 2 digits here, right? If I want them both to be even, how many even numbers do I have for the first spot? There are 10 even numbers? 5, 0, 2, 4, 6, and 8. So there are 5 possible numbers there. And I'm going to multiply that by the other one. How many possible even numbers do I have for the second space? Because I can't have doubles, there are 4. Because if I have a 2, I can't use a 2 on the other one because I can't have doubles. Does that make sense? So there are 4. Which means there are how many favorable? 20 out of 90, which is 2 over 9, which gives me roughly, give me 3 digits. 0.2, repeating, that's close enough. Okay. Next one. A set of 22 books, volumes 1 through 22, are in a crate. If a student randomly chooses 5 books from the crate, what is the probability that the student picks either the first 5 volumes or the last 5 volumes? Now, my question to you is, permutation or combination? Why? Why doesn't the order matter? I can pick 1, 2, 3, 4, and 5, or I could pick 5, 4, 3, 2, 1, or I could pick 2, 1, 3, 4, 5. Doesn't matter the order that I pick the books. It matters that I pick the certain ones. Does that make sense? Okay, so it's a combination. How many total books? Order does not matter. How many total books? 22. How many am I picking? 5. So what's my total for my probability going to be? Oh my. 334? Okay. So that's my total. And how many favorable outcomes do I have? I want to know. Listen, I want to know what the probability that a student picks either the first 5 or the last 5. First 5 or last 5? 2. There are 2. Either you're getting the first 5 or you're getting the last 5. That's it, just 2. So this is going to give you some kind of crazy decimal, 0 point, bunch of zeros. What's it give me? So the E negative 5 means you're going to have that many decimal places. So we have 1, 2, 3, 4, 5. And you got, I don't want the decimal there though. Okay, so we have 0, 0, 0, 0, 7, 5. Okay. Alright, moving on. This one, probability of independent and dependent events. For independent events, you just take the probability of A times the probability of B. For dependent events, you take the probability of A times the probability of B after A has been taken out. This is an example if we are dealing with you're drawing cards out of a deck. And after you draw the first one, you keep it in your pocket, and then you draw another one. Okay, so you have 2 separate probabilities, 2 separate totals in your denominator, right? Remember doing those? Okay, so the calculator is programmed to generate random integers from 1 to 100 inclusively when the enter button is pressed. If the enter button is pressed twice, what is the probability of getting a multiple of 20? Then a multiple greater than 90. So we want the probability of a multiple of 20 times the probability of a number greater than 90. So, how many numbers are there to choose from? 1 to 100, so 100 times something over 100. How many multiples of 20 did we say there were? 5. How many numbers greater than 90 are there? 10. Alright, so this is the same as saying 1 over 20 times 1 over 10 gives me 1 over 200. Everybody with me on that? Yeah? That's it. I know. Too easy, right? Alright, a bag contains 2 red and 6 blue marbles. What is the probability of picking a red marble, keeping it out of the bag, and then picking a blue marble? So, I want to know the probability of getting a red, right? Red times the probability of getting a blue without replacement. Okay, so what's the probability of getting a red marble? 2 out of 8 times the probability of getting a blue marble without replacement. 6 over 7, because there are no longer 8 marbles in the bag or whatever it is. So whenever I multiply those, I get final answer. With me on that? Yeah? All right. Odds. If you want the odds of an event, it's a little different than probability, and sometimes we get them confused. The odds, you want the number of favorable over unfavorable. Okay? So favorable to unfavorable. On the last example, we were talking about 2 red and 6 blue. If I said, what are the odds of drawing a red marble? You would say 2 out of 6, which would be 1/3. Okay, 1 to 3. Odds, different than probability. Which is what they just said here. Okay, so the odds, this is favorable to unfavorable, which is going to be favorable in this case. They want a red. Unfavorable, you don't want blue. 1/3. Reduce it. Still reduce it. The the odds of an event are 5 to 2. What is the probability of an event? Whenever you have this, we're talking about favorable, unfavorable, and a total. Because when we're talking about probability, we always need the total. So favorable is 5. Unfavorable is 2, which means the total is 7, because I have to add them. The probability of the event, that's my favorable, 5/7. Okay? Example 5, last example here. This is dealing with experimental probability. It says the table shows the number of tropical storms in the Atlantic, Caribbean, and Gulf of Mexico from 1851 through 2006. Construct an experimental probability model. And they want us to find the probability of a storm happening in each of these times. So for me to find the probability, I need to know the favorable and that's odds. I need to know the total. So the total number of storms would be how many? How am I going to figure it out? Add them up. So what is it? Say it again. Okay. So to find the experimental probability, all I'm going to do is take the number divided by the total. So 5 over 1354, 198 over 1354, 10, or blah, 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 over blah, blah, blah. Okay, so you need to do this, and you need to do lesson 55A through whatever it is. Okay, that's your assignment.